You see the word RC?
Yeah.
Chapter 3 Dynamics. Okay, basically there are 3 Newton laws attached to this chapter. I will go through each law bit by bit, then we'll call it a day today lah.
Okay.
This chapter is very important. Newton's first law. If you have your book, let me read out for you the first law. Yeah, I should write it. An object
Law of inertia.
yes. An object will continue to be at rest or in continuous linear motion unless a resultant force acts on it. Okay, these are the 3 main points. Okay, so I will use 2 examples to explain. If this box is already at rest, okay, it is not moving, it's at rest, not moving. It will continue to just relax and not move and just rest unless I exert a resultant force. Okay? Then it will start to move. Okay? Now, when I say a resultant force, I'm saying a force like this. Just sidetrack a little bit. I have a box on the ground. Now, if I exert a 5 Newton on this side and a 6 Newton on the other side, what is the resultant force?
1.
It's 1 Newtons to the left. Okay? Now, pointing to the left. Now, please take note. I would like to highlight this to you that resultant force is not a force. It is not a force. A force are things like weight, tension, friction. Resultant force is not a force. It is just a leftover force. The leftover is 1 Newton to the left. There's no status to this word resultant force. It is just leftover. You cannot say that this 1 Newton is a frictional force. No. It's just leftover. Okay? Now, what if both sides are 6?
There's no resultant.
So there's no resultant force. This will drop out. No resultant force. That brings us to the next part when if this object is at rest and I exert a force, 2 forces of 5 Newton, 1 on each side. What will happen to this object?
No.
No. It will just stay there because both will cancel each other out. I hope you understand this part.
Yes.
Okay, it's like I push my head here, it should move this way. Okay, but I push my head to the other side with the same force. It will just stay there. It will just stay there. Okay? That brings us to the next part for the continuous linear motion. Now, taking for example, this box is already moving. Already moving in a straight line. Moving in a straight line. On the diagram is towards the right hand side. It's already moving in a straight line with the constant velocity of 10 meters per second. It's already moving. And it is always moving at this speed. Now, it will continue to move with this speed there is a resultant force. If it's already moving to the right with 10 meters per second and I still push it with additional 10 newtons, what will happen to this speed?
Increase.
It will increase. It will accelerate. That will be the Newton's second law. Okay?
What if you insert energy from the other side?
Now what if this 10 newtons is not alone? It is accompanied by another 10 on the other side. Now, question is there a resultant force acting on the box? No resultant force. So it will just continue to move in a straight line with 10 meters per second.
Then if only that side, will it stop or
Okay, what happens if it's only on one side? What will happen to this box? Will it stop immediately?
or slow down?
It will not stop immediately. It will start to slow down. You ask yourself this question: if you are running, okay, or the car is moving, and you step on the brake, do you stop immediately?
No.
You slow down first before you stop. Okay? Unless the force is so weak that you immediately stop. Unless, but very, very weak. Okay? Because there's other things like conservation of energy involved in this, which we will not touch now. Okay, now Newton's first law we are quite clear. Okay, so the most important thing is you need to know how to find out resultant force and Newton's first law. It's also called the law of inertia. Okay, law of inertia. Second law.
The resultant force is the product of the mass and acceleration of moving.
Yes, the resultant force acting on an object is the product of the mass of the object and the acceleration the acceleration of the object. Now, if you realize in your book you don't see this little r here. Okay. Now the reason why I put this little r here is to re-emphasize the fact that this F is not a force, it is a leftover, it is resultant force. F is the force resultant. Okay? So basically this law is quite self-explanatory. If the object is moving with constant speed, if the object is moving with constant speed, is the object accelerating? Quite clear cut. If it's not accelerating, which means my A is, can you give me a numerical value?
0.
0. And it also tells us that there is no resultant force acting on the object. So one trick that you will definitely use is in the event the MCQ tell you object is moving with constant velocity, what is the resultant force acting on the object? Your reaction will immediately be zero. Okay, even though they give you one whole big chunk of information, once you see the word constant velocity, you know this is zero. Okay, but let me just highlight to you another common question that will be asked. This box is moving with a constant velocity of 2 meters per second. Okay, now, in order for this box to move, I need to exert a force, right? Pushing this way, right? Right? Let's say this force is 10 meters. Okay? And I say, object is moving with a constant speed. Immediately, what can we imply? Resultant force is 0 newtons. Right? We can imply this immediately because we have already concluded that because there's no A, there's no FR. Now, question is, friction. You take some time to think about it. The pushing force is 10 newtons. There's no resultant force. What's the amount of friction acting on the box?